Hey everybody, Mr. Boatman here. In this video, we're going to go through a practice task for 1.13 elements of chance. The way the video is going to work, along the bottom in the time bar, you'll see kind of 4 chunks. The first one, which is this chunk, will be me going through the task. Then I'll have an achieved part, a merit part, and an excellence part. To make your life easier, when I start typing, I'm going to color code everything. The achieved stuff will be in red. The merit stuff, I'll switch over to blue font. And the excellent stuff I'm going to put in the pink font. Alright, so let's get into the task. So at my school, Kaipara College, we've got this thing called Pride Cards. And there are 5 different types of cards, one for each letter. So one for P, one for R, one for I, one for D, one for E. I'm sure the people from my class already know all this stuff. And what's happening is we're getting rid of those pride cards, and we're getting a new value called the Waka cards. So to celebrate the end of the pride cards, the deans are going to be putting on the celebratory lunch. During the lunch, students are going to be given 2 pride cards randomly, and based on what cards you get, there's a possibility of winning a prize from the school canteen. And there's a bit of truth to this because at our school, students can cash in these pride cards for stuff from the food from the canteen. So the way it works, I've got it highlighted there. If you get the P pride card, that's going to be worth 4 points. If you get the R card, that's going to be worth 3 points. If you get the I card, that's 2 points. And if you get either of the other ones, D or E, that's just going to be worth 1 point. Based on the points you get, that kind of decides what prize you're going to have. 8 points is going to be the beef and cheeseburger. 7 points is going to get you some wedges. 6 points is going to get you a muffin. And down the bottom, 5 or less, you're not going to get any prizes for those, unfortunately. And what we've been asked is the deans have asked us to analyze, I've written an analysis there, but analyze the probability of a student winning a prize and the probability of each of the prizes being won specifically. So what I'm going to do is I'm going to skip all this stuff. Hopefully you're familiar with what you need to do at each part. And as I said, red achieved, blue merit, and pink excellence. And I'm going to scroll down to my model answer. The first thing I do when I start an internal is I always write a bit of a skeleton answer, and that's what the colors are here. It's just some points or notes for me to remember to discuss something. So underneath this red heading, I'm going to write down the question, and then I'm going to write down my expectations and so on. Okay, so let's get into the achieved section. And the achieved section is going to mainly revolve around us planning it. So I guess the main thing to note is we've been asked to calculate the probability of a student winning a prize. And in this case, winning a prize is someone getting 6, 7, or 8 points from the pride cards. So that's the scenario we're investigating. So let's scroll down. So our investigative question, that's not in red. What is the probability of a random student who receives 2 pride cards? Let's do them in capital letters. Scoring 6, 7, or 8 points. Notice in this, I didn't talk about prizes. I didn't talk about muffins or cheeseburgers or whatever it might have been. I didn't talk about the context. I've linked it to the probability, the outcomes that I'm thinking about, and the outcomes are all of these points. So that's my investigative question sorted. So scrolling down after that, the next thing you need to do for achieved is you need to come up with just a basic plan, just some step-by-step guides that you can pass on to someone else to follow. So this one here is going to be a bit annoying. So I've got 2 pride cards, and I just want to show you what I think I'm using. So if you just open up a Google search, which I've got here, and I'm just going to Google search jewel spinners, and you'll see here, jewel spinners, that first link that comes up, this is the tool that comes to mind. You'll see it's going to load a bit slow. There you go. And it initially comes up with 1, but eventually it's going to load up and come up with 2. So what I'm thinking here is I can update the outcomes here, and this can represent the first card the student's going to get. And then I can do the same over here, and that can represent the second card that the student's going to get. So now that I've got an idea of what I'm trying to achieve, I'll show you what I mean by that. So I'm gonna go PRIDE. So that's pride, and I'm just gonna copy that because I'm gonna I'll paste it over on the other side as well. Oh gosh, that didn't go well. Control A, there you go, Control V. So you see the wheels updated for whatever we told it to. And if we click spin all, this is just an example, not part of our experiment. Click spin all. It mimics 2 random cards being given to a student. So in this case, the student would have been given an I card and a P card. That there I think was 6 points. I think it was 4 and 2. So that person may have got a prize in this case. And we can repeat this 30 times to do our simulation. So I'm thinking that's what we're going to use. So back over to my experiment, let's start describing this in steps so I can pass it on to someone else. So step 1, I will open up dual spinners and type pride as the 5 options. So that's step number 1. Step 2, I will spin both wheels to simulate a random student being given 2 pride cards. Step 3, I will record the spin in my table and calculate how many points they get and what prize they win. So step number 4, I will repeat this process until I have 30 trials completed. And then following this, we need to analyze all our data. We're going to, I will copy my data to NZ Grapher. Step 5, I will create my bar graph and relative frequency graph. There we go. So those are my steps. So I think they're nice, easy ones. So just to recap, step number 1, dual spinners. We're going to put in the 5 options. I'm going to spin both wheels like I did to simulate. I just realized I've spelled that wrong. To simulate a random student. I'm going to record my data. I'm going to then do this until I have 30 trials completed. I'm going to go to NZ Grapher and I'm going to create my graph. So that's a pretty basic one. There's a bit more details I could have added, and just noting that's what the merit criteria down there is talking about. So let's scroll down. So the next thing that we need is this describing the possible outcomes section. So that's the last achieve criteria in that plan section. And I was a bit naughty. I didn't actually write that as a heading. So describe outcomes is what I'm going to be doing next. So the outcomes that I get do depend on the points that we receive. So there are several different outcomes in relation to this. So first, number 1, the first outcome, and this is when we're going to need to know the prizes. So we had the beef and cheeseburger, the wedges, and the muffin. So scoring 8 points, because that's the highest you can get, because the P is with 4, so 4 plus 4 is 8. Scoring 8 points, scoring 7 points, scoring 6 points, and then scoring 5 or less points. So that last one captures all of the other ones that aren't winning a prize. So scoring 8 points, that relates to winning a cheeseburger. Oh, sorry, beef and cheeseburger, I should say. Beef and cheese burger. 7 points was winning wedges. This wins some wedges. And then scoring 6 points, this wins a muffin. And then the last one is no prize. So we've considered all the outcomes. It's probably best to give an example of each. So for example, that's the PP one. That would be 4 points. Oh, so 4 points getting us to 8 in total. For example, this one here has got to be P and R, or it can be R and P. Could be either way around. Getting the muffin, there's a few different options here. It could be P and I. It could be I and then P, or it could be the two R's, which are 3 points each. So you can kind of see it. It looks like it gets, because there's less possibilities, it looks like it's getting more and more likely as the things go down. So that is the describing the outcome section. I think that's pretty comprehensive. We've related the points to the cards, and then we've related to the context, or in this case, the prize that happens. So let's scroll down a bit more, and we're going to get into the table section here. And annoyingly, you're not going to be given a table. It's your job to come up with it. But if there's one thing you need to remember, we need 5 columns. So make sure you have 5 columns in your table. So what we're going to go is we're going to go insert table, and you can see I've gone 5 wide, and I'm just going to click down. I'll just I'll just do 12, and we can add some more later on. So the first one is going to relate to my trial number, and that's when you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Obviously we'll increase this to 30 because we'll need to do 30. Let's bold the top ones. The next one relates to spinner outcomes. Following that, for example, we had I, P initially. We'll delete this one because it's not a valid trial. The one after that, we had points. And we figured out that this one there was actually 6 points, so they would have won a muffin. Prize outcome, so they won a muffin. And then finally, this one's going to be a bit weird. Probability of prize, because we were asked about the probability of a prize by the deans. And I do want to disclaim, this one's not needed for achieved. So not needed for achieved. So what I'm going to do is I'm going to highlight that, and I'm going to make that pink, because that, oh gosh, I've highlighted too much. That relates to actually an excellence thing that I'll run through later on in this video. So let's get rid of this one that we messed around with. Before we start though, I do want to make something really clear. This prize column here, you have to be really, really exact with your writing. So if you go, for example, muffin with a capital M, and then muffin with a lowercase m, when we put this information onto NZgrapher, it's not going to have a good time. So we need to be exactly the same. So above, or what I'm thinking here is, our prizes, we're going to use M, or we used beef. So B for beef, oh gosh, I keep spelling right, beef and cheeseburger. We're going to use W for the wedges. That way I can't risk misspelling anything. We're going to use M for muffin. And we're going to use NP for no prize. So the reason I'm doing this is it's going to be pretty tough to get B wrong. Okay, so let's go to our dual spinners and let's get into it. So let's go spin number 1. So we've got E and D. So we've got E, D, and the points here, don't forget E and D, they were the last two. They were 1 point each. And it might actually pay for us to do this. So P was 4 points because we're spelling out pride, 3 points. I was 2, D was 1, and E was 1, just so I don't make a mistake. So that's going to be 2 points. And the outcome here, well, they got a no prize. So back to the spin. I'm not going to do all the spins. Maybe we'll do 5 together, and then I'll pause the video to do the rest. So this person here got I and E by the looks of it. So we've got I, E. So an I was 2 points and an E was 1 point. So that's 3 points. And again, no prize. And maybe over here, we just write that there was 8 points. that there was 7 points. This is really just to make sure I don't make any math mistakes. And that was 5 or less. Okay, so no prizes yet. Let's do a couple more together. So let's close out of this and we go spin. We've got P and P. That's the good one, the good combination. So P comma P, that there is 8 points, and that was the hardest prize to get. That was the burger. And there we go. That was confirming that. We've got E and R. Good. So E comma R, and that there is 4 points. And close, but no prize. Oh, I've only spun one. So we got an E over here. Oh, it only let me spin one. Let's delete that one. Let's just ignore that E. There we go. Doing both. We've got R and P. I think that's going to be a good prize again. P comma R. Those are the top 2 ones. That's going to be 7 points. And this person here would have won some wedges. So maybe we'll do 3 more together. Let's spin this. We've got P and I. P comma I, and that there is going to be 6 points. That's another prize. This one, a muffin. Let's spin this again. We've got R and P. So that's another 7. We've had a good run, actually. So that's 7, and they won the wedges. And then we'll do the last spin together, and then I'll pause the video and we'll... geez, a really good run. Double P. So, P and P. So that's 8. And they won the burger, the best prize. Oh, I've written it in. Burger. So at this stage here, I'm going to pause the video. I'm going to complete my table up into a 30 trials. If you're wondering how to add extra rows, you just go right-click, insert row below. And you might just have to do this a few times until you get the number that you need. Okay, pausing now. Hopefully you'll see a complete table in now. Okay, we've got our complete table. Hopefully you're happy with that. And what I've done is I've got, or the key parts here are the points and the no prizes. And I'm going to create a couple graphs based on these two here. So at this stage here, if we scroll down a little bit to see what's next, our goal is to create a couple graphs that represent our probability investigation. And there's actually a few graphs we can have, because we could investigate the points that were coming up, or we can investigate the prizes that are coming up. So there's actually quite a few graphs that we could look at here. We'll do both for the video, but just knowing in the real internal, if you analyzed one of the two only, that's all good. So let's start off with the prizes, because that's the similar one that we've done to the stuff in class. So what we're going to do is we're going to copy the prize column like this. We do have to do it one by one, unfortunately, because NZGrapher won't like it if we try to do both at the same time. So we're going to go right-click, copy. So that's now on my clipboard. I've Google searched NZGrapher before, so I just Google NZGrapher, and we click on the link, and it comes up, and we click on the blue Start Using NZGrapher part. And because it's on our clipboard, because it's copied ready to go, we're going to go import from clipboard. You also could have done paste table, but let's do import. And then you can see my heading prizes, and I've got all the different prizes that were won. Now we're going to start off by looking at some bar graphs. So we've clicked bar graph, so we've gone to the graph type, we've clicked bar graph, and nothing comes up because we haven't told it what category, what variable to investigate, and that's what this one here is. And we only copied over one, so prize is the only one that we're looking at. And there we go, these are all our things. So we had 4 different outcomes. Could have been, burgers, wedges, muffins, no prizes. If you had a 5th column or a 6th column, that's when those typos come in. It'll pick the typos up and do 2 graphs for the same one. So I'm going to click summaries. You'll see down here summaries, and that tells you how many times each of them came up. So we had 3 wedges, 3 burgers, 4 muffins, and 20 people unfortunately didn't win any prizes. The only thing I want to do is it defaults to graph title. I'm just going to change that and it could just be anything. But I'm just going to say prizes won from Pride cards. So, something very plain and descriptive. You'll notice my heading actually didn't update because I need to click this update graph down the bottom there. And it's going to change it for me. So that's my first graph. So I'm going to copy this one over. Copy. And I'm going to paste it in the bar graph section. So just a note, I'm going to come back and put another graph there when we go ahead and analyze all the numbers, but you only need to do one of them if you're only aiming for achieved. If you're aiming for merit or excellence, it might pay to do both. So relative frequencies, this one's going to be super easy. It's literally one click. Hopefully you can see down the bottom there, it's a bit small, but relative that's short for frequencies. We're going to click on that. And you'll see it's changed the numbers to probabilities. So we don't even need to calculate the probabilities because NZGraph is very nice and done that for us. So let's go copy. And then let's paste that over there. So those are my two graphs in relation to the prizes. I'm now actually going to do the same for the points that people scored, because it might be interesting to see how the points differed throughout the experiment. So let's go Control C. And I'm going to go back to NZGrapher. I'm going to go Data Import. And I've imported all the points. You can see them come up here. And we're going to go About. We're going to go a bar graph again. And finally, we need to tell it to analyze the points. Even though it's obvious and it's the only thing we copied over, NZGrapher, we still need to. And there you go. We can see all of the different ones. And I'll just click off relative frequency. And you'll see the bar graph that's come up. So you see 7 times people got 2 points. This one's weird. You see, notice it just goes down perfectly, except for 3. For some reason, there weren't many 3s. And then we got 6s. We've got 5 people getting 5, 4 people getting 6, and 3 people getting 7 and 8. The only thing to note is it's got my heading regarding the prizes. We just need to change that to be something to do with points. So points scored, let's maybe make that capital S, from Pride card. So points scored, and that's a pretty good graph. So let's copy this one over. There it is. We're going to go down to our bar graph section. And I'm just going to do a couple of enters, and I'm going to paste my points one. And below this, I'm going to do the same for my for the relative frequency graph. So I'm going to click over here, relative frequencies. We're going to go right click, copy image, and we're going to paste that over as well. So you can see the most likely one, 23% of the time roughly, people were getting 2 points, which is one of the no prizes. So I've got all my graphs, so that's looking really good. The only other graph you're going to need is, they're just noting that's in pink. That's one of those excellence criterias. So keep an eye on later in the video if you're interested in that. So we are now on the probability comments section. And this here is really, for achieved, just 2 comments. 2 comments. In relation to any of the graphs that you've calculated. So honestly, could be any of them whatsoever. Let's talk about, oh gosh, I've gone up too quick. Let's maybe talk about this this prize type stuff, and then maybe later on we can talk about the other ones. So the probability of winning a prize, or sorry, not winning a prize, was 0.6667. So that's the first thing we can do. And that's because it was 20 times out of the 30. So that'll be our first comment. Oh gosh, it's meant to be in red, but I'll fix that later. The probability of winning a prize, of not winning a prize, was 0.66667. This is because there were 20 no prizes from our 30 trials. So just highlighting this first part in red, because that's the achieve criteria. And I've used that word because I'm justifying what I'm doing out of the 30 trials. So just so you know, that there would have been the merit stuff, and obviously I'll get to the rest of those later on. But just so you're aware of how easy it is to add on to merit for that particular section. Other things we could have commented about, the prizes individually. So the probability of winning one of those burgers was 0.1. So the probability of winning a beef and cheese burger oh gosh, burger was 0.1. Noticing I'm not doing any of that blue stuff now because I'm not justifying it. I can then talk about the probability of winning a muffin, which was 0.133333. The probability of winning a muffin was 0.133333. Again, not doing because, and just a reminder, I only need 2 of these comments to get that achieve mark. I don't need much more. I'm just giving some examples. And then the last one was the wedges. That was also 0.1. The probability of winning wedges was 0.1. So that was analyzing that top graph. We could actually go ahead and analyze the bottom graph in a bit more detail. That was the points scored one. But the main one that's probably of interest is the probability of winning a prize. That was 6, 7, and 8 all added together. So the probability of scoring 6 or more points, which means winning a prize, was 0.3333. And that was, just a reminder, these ones here all added together. So I could have analyzed scoring, and that was meant to be prize. I could have analyzed this one a bit more. I could have said the probability of getting 4 points was 0.2. I could have said the most likely outcome was getting 2 points, which is 0.33333, which is not winning a prize. I could have said heaps and heaps more, but you only need to make 2 probability comments to get that. The obvious one was the most likely points scored was 2 points with a probability of 0.2333. So that's probably a good one to add, which one was the most likely scenario. Okay, so I've done that. My last thing is just answering the question that I posed to myself earlier before. So let's get back to the red font. So scrolling up, let's reread the question to figure out what we're actually trying to answer. The question we asked was, what was the probability of a random student who received 2 pride cards scoring 6, 7, or 8 points? We've gone ahead and already calculated that. That was this line here, 6 or more points. So we know the probability of a student winning a prize. That was 0.33333, or 1 in 3 of the students would win the prize. So the probability of a random student winning a prize was 0.33333, or 1 in 3 students would win. Full stop. So I could probably go into a bit more detail here because I didn't mention the 6, 7, or 8 thing. So the probability of a student winning the prize, i.e. scoring 6, 7, or 8, was 0.333. So that wraps up the achieve stuff. I know it was a pretty long video, but hopefully it was enough detail to get you going. But key thing I want to emphasize, you only need 2 of these probability comments. I would probably go for the most likely outcome. That's normally the easiest one to see. That's just the tallest bar. And then probably the one that relates to the question that you've posed. Okay, we are now into the merit section of this report. So we left off with the achieved stuff. So let's scroll up. Just a reminder, all that red stuff was achieved. The blue add-ons from our schedule are over here, and I've got the blue headings to kind of help remind us. So the first merit section was the expectation. That's kind of like a prediction. What do you think's going to happen? So when you think of the pride cards, we know getting PP, when we consider the outcomes down below. So when getting PP, that was only 1 option to win the beef and cheese. There were 2 options to win the wedges, and there were 3 options to win the muffins. So that kind of tells us, because there's more options, they're slowly getting more likely to happen. So from our outcomes, actually, we don't even need to say that because the justification is the excellence part, so we can talk about that later. So I would expect the probability of scoring 8 points, and then we're going to go winning a beef and cheese burger to be the least likely outcome. And again, we can justify that later on. I would expect scoring 7 points would be the next one, and that was winning wedges. And then finally, I would expect scoring 6 points would be more likely than 7 or 8. And then you could probably talk about, you're probably going to be giving away more, probably most of the students will not win a prize than win a prize. And then in addition to this, I would expect more students to not win a prize than win a prize. So notice here I didn't justify anything. It's just what I was expecting based on the outcomes that I looked at in the achieve section. And later on in pink, we'll go back and we'll justify that. We'll use that word because we're explaining what we're doing and why we're doing it. So next one here. So steps, sufficient detail for someone to replicate it. That's the next merit section. We actually did a pretty good job before. We're just probably going to pad out a few blue parts there. So I will open dual spinners and type the 5 options. You could probably say link here. Maybe give that link to make their life a little bit easier. So there is our link. Let's highlight this blue. This is all the merit add-ons that we're looking to do. I'm just going to do it there. I will spin both wheels to simulate giving two pride cards. That's all good. I will record the data in my following table. We could maybe add a little bit more detail, like what does the table actually look like? The heading of the table is outlined below. And then we'll just copy and paste the first two ones. That way someone can just see how the table gets set out. There we go. So that's what the table looks like. So they can see that. That'll certainly make their life a bit clearer if they were trying to replicate our experiment. And let's highlight that blue so we can distinguish it. Okay, the next one, I'll repeat this until I've completed 30 trials. Perfect. I will copy my data into NZ Grapher. So probably a bit more detail here because we ended up doing 2. I will start with the prizes data. So that there is the merit stuff. So let's make that blue. And then it says I will create the bar chart and the frequency graph for the prizes data. Because remembering I did 2, so they probably wouldn't know this if we didn't tell them. And then finally, step 8, I will repeat steps 5 and 6 for the points data. And again, that was something that maybe wasn't as obvious as well. So there you go. So I think adding in that little extra detail certainly makes it a bit clearer, and that will certainly be a more comprehensive, a more full plan. So the next one to think about is sources of variation. That's stuff we're trying to control in our experiment. This sources of variation stuff is often quite tricky, but going back to the question or the context of the scenario, this is where you're going to spot the sources of variation, is so that word random there. So I'll highlight that in yellow actually. So if we did this with actual cards and we shuffled them up, that shuffling process isn't fully random. Like, maybe all the R cards are going to be next to each other, or the E cards will still be next to each other or whatever. So because the scenario has described us a random one, we need to manage this idea of variation. So we need to make sure our real simulation, whatever we decide to generate these cards, actually replicates this randomness. So the variation here that I want to talk about is probably the randomness. I want to make sure it's actually happening. Okay, so where are we? Sources of variation above the graphs. There we go. So let's get into this. So oh gosh, I'm having a nightmare here. the scenario emphasizes that the cards are going to be distributed randomly. In the real world, randomness is difficult to obtain and may not happen depending on the individuals involved. And then we give some examples. For example, if we used actual pride cards, someone's shuffling may be really good, which results in random cards. However, someone else's shuffling may not be as good, which results in a group of peas being stuck together. The latter would not be random. This variation is something I have tried to control in my simulation. The latter, there you go, 2 T's. There you go. So hopefully that makes sense. So that variation, I've described 2 people. Someone who's maybe played a lot of card games, they might be really good at shuffling and they might get that random effect. Someone else, for example, they may grab a clump of P's, a clump of R's, a clump of I's. They may give them a quick shuffle, but those letters may still be grouped together. So they might not actually be random. They might just be stuck in the same spot. And, maybe if all the P's are on the top, it's the first kids coming in will get the P, and the other kids are unlikely to get them. Okay, so we'll chat about that in a bit more detail for excellence later on. So we're now scrolling down. So we've got our table, we've got our graphs. Awesome. The next thing we need to do is we need to justify our probability comments. And this here is that because word. So the probability was this because of whatever. So we did that in the first one to show you there were 20 no prizes from the 30 trials. We now need to replicate that for the cheeseburgers. So how many cheeseburgers were there? Going up to my first graph, you'll see my prizes. B for beef and cheeseburger, so there were 3 of those. So that's 3 out of the 30. So let's copy this, just because I'm going to be a bit lazy. There we go. This is because there were 3 out of the 30 trials. We know that the probability of winning a muffin, I'm pretty sure that was 4. Let's scroll up to double check. Yep, 4 muffins, and we saw at the same time there were 3 no prizes. So let's change this a bit here. So this is because there were 3 beef and cheeseburgers, 1 out of the 30 trials. So let's change that. That means there were 4 muffins, 1 from the 30 trials. And then finally, this is because there were 3, this is the wedges, isn't it? 3 wedges, 1 from the 30 trials. There we go. So that's the blue stuff. The next ones are a little bit harder. The probability of scoring 6 or more was 3.33333, and we did that because we added together the probability of 6, 7, and 8. This is because we added together the probability of 6 plus the probability of 7 plus the probability of 8. And each of those probabilities, maybe just put them in brackets, 1, 3, 3, 3, 3, 3, and then 7 was 0.1, and 8 was also 0.1. And we'll highlight that sentence in blue just to highlight that this is because we're justifying that's a merit answer. And then finally, the most likely point scored was 2. 2 points, And that's because how many 2 points were there? There were 7 of the 30 scored a 2 points. So this is because 7 of the 30 students in our trials scored 2 points. Okay, so we're going to get that in blue. And we're down to one last part. We've got to justify our answer. And we've actually done pretty well justifying it already, to be honest, because we've got all the probabilities in there, which is normally a good sign. But like we did before, we're just going to do the same thing here. This is because we added together the probability of 6, which was winning the... well, 6. 6 was the muffin, wasn't it? Probability was 6. And then so on. So that last bit there, justifying the conclusion, ended up being quite similar to one of our calculations because it was the same thing. So that wraps up the justifying part. That's all the merit stuff. So that's all the blue stuff. We're going to scroll back up to the top, and we're now going to start thinking about the excellence add-ons, which will be in pink. So the first pink criteria was justifying the expectation that we had. That was our discussion that, the cheeseburger was the least likely prize because only one of the combinations would get there. So what we're going to do is we're just going to add in, why. So this is because only one combination of pride cards, being PP, would result in scoring 8 points. We'll say scoring 8 points. So let's highlight that in pink. Just above, I won't do it below. Same thing here, we're going to replicate this, but winning the wedges, we found out there were 2 outcomes. It was PR or R and P, so that meant it was twice as likely to happen. This is because there were 2 combination, oh gosh, I'm having a nightmare with the spelling, combinations of pride cards being PR and RP, which would result in scoring 7 points. So highlighting that pink again. And finally, even though there might be more, we're going to think about the 6 points one. So this is because there were 3 combinations of pride cards. In this case, it was being RR and it was PI and IP, which would result in scoring 6 points. So highlighting that in pink, and then what that means is all the other combinations, and there's heaps and heaps left. All of the other combinations would have been the no prize. So this is because every other combination would result in a no prize. And I just do note which exceeds, so all those combinations which would exceed 6 other combinations. So I'm not going to do them all exactly, but we know there's going to be way more than 6 more combinations with all the other letters. And because it's more than the 6 here, we know that this one here has to be more than half of the probabilities. So let's highlight it in pink. So I've justified my expectations. This is a good one to think about because later on we're going to need to talk about all the different outcomes anyway. We just did that a little bit earlier than we meant to. So in the plan section, sufficient detail, it needs to be really comprehensive for excellence. We won't go over that in too much detail here, but we've actually done quite a good job here, to be honest. Sources of variation, this is the next part for excellence. This is really convincing the marker that you know your stuff about sources of variation. So let's scroll up just to see the difference. So you notice here, it says suitable plan without guidance, blah, blah, blah. And it says an attempt to manage sources of variation between the experiments. And it just says a comprehensive plan. So we probably want to go, given sources of variations was mentioned here, And we do think someone else will have enough detail to replicate it already for merit. Probably just need to convince the marker about this variation stuff. Okay, so recapping what we did, this scenario of the cards randomly distributed. This variation is something that I'm trying to control in my simulation. Okay, and we've really just explained what the problem was. We haven't actually explained what our solution is, so let's maybe just explain that in a bit more detail. I will resolve, or I will manage this source of variation by ensuring we use an online random generator to make sure there is no inconsistencies in the shuffling. To make the trials easier on myself, I have elected to use the dual spinner tool. This will let me randomly generate two prize cards for each trial. And then maybe we'll do a picture. See picture below. So we're going to go into the spinner section. I'm just going to use my snipping tool here. Just to grab that. That way I can just show what it kind of looks like. Ideally, my snippet would have the pride values in it, but I'm sure they'll be able to figure it out. Okay, so I'm liking that. I've gone through a bit more detail. This is to ensure there we go. Really try to convince the marker that I know my stuff. And I just want to know my blue stuff. I probably maybe did the blue stuff a bit too good, because there wasn't actually too much for me to add in this section. So the next thing we need to do is, I did say this pink column here was going to be the probability of winning a prize. And I've just noted we added that column because the dean specifically asked us, and this is the point of our question, what's the probability of winning a prize? So for this first person here, there was one trial done, so it is 0 out of 1, which was 0. The next one here, still no prize, so 0 out of 2 of the people have done that. And then finally we won a prize, so 1 out of 3 have won that. And what we're going to do is we're going to keep going until we've done that. So because we're going to need the decimal numbers from the for NZ graph, I'm just going to insert another column to the right, just so we can have the actual numbers. So that there was 0, 0, 0.3333, and I'm going to round it to 4 dp. Probability rounded to 4 dp. So it was 1 out of 3. This one here is 1 out of 4. So that's 0.25. I'm just going to do the first couple with us, and then I'll complete the whole thing by myself. So we've got another prize, 2 out of 5. That there was 0.4 now. If you're wondering where I got 0.4, that was 2 divided by 5. We've now got another prize, so that's 3 out of 6. So that's 0.5. We've got another prize, 4 out of 7, which I just got my calculator for, 0.5714. We've now got 5 out of 8. This is when we had a good run, so that's going to be 0.625. We've then got no prize, so that's 5 out of 9. This one here is 0.555. And then the last one we'll do together, 5 out of 10. We're back to 0.5. So I'm going to pause the video. I'm just going to complete these columns, and then we're going to need to just graph this information here to see what it looks like. All right, so you're going to have to go with this one with me to make it work. So NZ graph is a bit annoying. It doesn't do these graphs as nice. But what we want to do is we want to copy the entire table. Weird, I know, but go with me. We're going to go Control-C, and I've got a blank Google Sheet, and I'm just going to paste all of that information into. So I pasted it all in there. And what I'm going to do is, to make EasyGraph work, I just need to mess around with these trial numbers to get it to a particular format. So I'm going to write 2023 because it's currently 2023, and D for day. Don't ask why. And then I'm going to write 01. And then the next one there is going to be the exact same, except it's going to be with 2 instead. So we're going to go Control C, Control V, but it's going to be day 2. So you can see I've got day 1, day 2. And what I'm going to do is I'm going to highlight both of those. And you see that little blue dot there? I'm just going to drag it down. And that will change all the days for me. So you can see day 3, day 4, day 5, day 6, and so on all the way to day 30. So it's a bit annoying, but we just need to do this to make EasyGraph do what we want. Once we've done that, I'm going to go Control A. So I'm going to copy my entire table, and then I'm going to go Control C. So it's now in my clipboard. Over to EasyGraph, and I'm going to go Data, Import from Clipboard. And you'll see all my data's come up, including my days stuff, and the probabilities at the end that are really important. The ones in the middle, I don't need those at all, but just needed to do that to make it work. So this is going to be weird, don't ask me. But I'm going to scroll down to something called Time Series Graph. So I'm going to click Time Series Graph, and my variable number 1 is going to be the trial number. Noting trial number is the one with all the date, the day, and the year stuff that I made up. That's why we ended up in the time series graph. And then the variable I want to compare is probability rounded to 4dp. So that's that last one there. And you'll see the graph come up really nicely. So it's a nice little line graph. I'm going to go label points. So I click that down there. That way you can see point 1, point 2, point 3, point 4. And you kind of can describe this in a bit more detail if you wanted to. And I'm going to update my graph title to changing experimental probabilities, probability for prizes 1. And we're going to go update graph. So this graph here is going to be the one that we need to copy. My only thing to note is ignore the years. So when you use your snip, so instead of copying and pasting, let's go to the snipping tool we're on before. Let's just snip everything. And notice I'm going to stop just above the years. That way I've cropped those out. So you can see that graph looks pretty good from there. So I'm going to go right click, copy. We're going to go to the work. We're going to scroll down to the data section. And that's where the change in probability graph happens. So Control V. There we go. So we can see our graph. So what this means is we can see how the probability it goes up, it goes down, goes up, goes down, goes up, goes down, and then it eventually ends up roughly near the exact probability of the event. So we'll be able to talk about that in a bit more detail shortly. So that's that graph. We've justified all this. The next excellence thing was the distribution comments, and the distribution comments relates to the points scored graph that we've got here. And you can see the distribution. Do you see how it starts quite tall on the left and then it does go down as we go to the right? So what that means is these outcomes over here are more likely to occur than these outcomes over here. So you can see, the information on the right hand side is smaller. So we call that a right skew because it's kind of like someone pulling the data from this side. So that's a right tail. So that means it's right skewed. So let's go down. Let's just discuss that in a bit of detail. We don't need to go into too much detail, but the distribution of the probability of points, having nightmare spelling, points scored appears to be right skewed, i.e. right hand side of the graph is smaller than the left hand side of the graph. So just to clarify, I probably want to talk about some details just to clarify this. For example, the probability of getting 2 points was 0.23333. We can scroll up just to double check that number, and I'm going to ignore the 3.1 just because it's a bit of an outlier. I'll talk about that later. And you can see the probability gets progressively lower until we get to the end of it. So it's 2, 1, 6, 6, 6, 7, 1, 3, 3, 3, 3, and then 0.1. Following this, the probability of getting the score drops between 4 points and 8 points, i.e. Each getting more likely to occur. We can then talk about point 3 specifically. It was a bit weird, wasn't it? It was just a random drop, and that was actually the least likely outcome to happen. Despite the lowering, I spelled that wrong, lowering distribution, the probability of scoring a 3 was the least likely outcome, based on our experiment. And then probability of I think it was 0.06667. I'll scroll up just to double check that. Yeah, good. And maybe make a comment. This was less likely than winning the best prize of a beef and cheese burger. There you go. So I guess the main thing is we've talked about that as right skewed. I'll change that to ED. Right skewed. Don't forget it's lower on the right, which means it's right skewed. If it was lower on the left, it would be left skewed. We've talked about kind of what that means, that the probability of a 2 was the highest, and then it got lower, and it dropped between 4 and 8 points. And we've talked about that weird one, probability of 3 being a lot less. So I think that's some good distribution comments right there. So we're now going to chat about the last 2 points, which is improving the experiment, and the last one, some insightful probability comments. So let's start off with those insightful comments. And there's 2 things you need to do here. Basically, the first one is compare with theoretical probability. And then the next one is compare experimental probability over time. And that's that other graph that we created before. So let's start off with the comparing the theoretical probability one. And to compare this, we're actually going to create a little bit of a table just so we can do the work a bit better. So there's 5 letters in Pride. So there's 5 different options. So I need to make a table that's 6 by 6 just to accommodate a heading. So we're going to go 6 by 6. So there's my table. And so let's say the outcomes along the top here, they represent the first card that I was given as part of this prize. So I could have got any of the Pride numbers, right? Or any of the Pride letters. So I'm going to do Pride. And to make my life easier, I'm just going to write 4 in brackets because the P is worth 4 points. That's worth 3 points. That's worth 2 points. That's worth 1 point. And then finally the E is also worth 1. I'm now going to do the same for the going down. So going down, same thing. It's the second card. I could have got any of the Pride letters. So let's put all of those in as well. Oh, I've run 5. That's definitely not 5. There we go. So the I was worth 2, and the D and the E were worth 1 point each. And what I'm going to do here is I'm going to, in this area here, I'm going to find all of the, these represent all the possible outcomes. Every single outcome represented there. There's 25 different outcomes that could have happened. So we're going to calculate the theoretical probability. So this one here would have been 8 points because it represents the 4 for the first card and the 4 for the second card. I'm going to add them together. This one here represents the 3 for the first card and the 4 for the second card. So that's a 7. And down here we got 2 for the first card, 4 for the second card. So that's a 6. Here we got 1 for the first card and 4 for the second card. So that's a 5. And this is 1 and 4 again. So also going to be a 5. The next one here, that represents a 4 and a 3. So we'll go 7. I'll do this row in more detail, then I'll speed up the other ones. So this one's a 3 and a 3. So that one's actually a 6. We've got a 2 and a 3, which is 5. We've got a 1 and a 3, which is 4. And then finally, it'll be the same one. We got 1 and 3. Oh, that's had a bit of a nightmare. 1 over there, 3 across the side. So that comes to 4. So I'll more quickly run through these ones. You can actually see a pattern here. So it's going down every time. So that there would have been 6 and 5. That one being the same. It would have been 5 over here, 4 over here, 4 over here. And then we've got 4 over there, 3 over there, 3 over there. And then we've got 1 and 2, so that's another 3. And then we've got 2, 2. And then finally we've got 3, 2, 2. So these represent all the different possible outcomes. So let's calculate some probabilities from this. So from the table, we know that there were 25 different outcomes that students could have received from their pride cards. So the probability of an 8, which is the beef and cheeseburger, that was equal to, if you see, there was 1 8 out of all 25, so that was 1 over 25. I'll convert these all to decimals later on. The probability of a 7, which was the wedges. How many 7s can we see? We can see 2 7s there and there, so we've got 2 7s, so that's 2 out of 25. The probability of getting a 6, which was the muffin. How many 6s do we see? We see 1, 2, 3. So that there is 3 out of 25. And you notice that actually matches the outcomes we talked about before, 1, 2, and 3. And all of the other ones, probability of 5 or less, which is the no prize outcomes. All of the other options, and we've got 6 of them already counted for. So these all, the first 3, that's 6 of the outcomes. So the other 19 would be the no prize options. So let's convert these all to decimals. I've got my phone here just to help me out with that. So the probability of getting that 1 divided by 25 is 0.04. And just noting, we got 0.1, so we actually got quite a lot higher than that number. This one here is going to be 0.08. So we got 0.1 for that again. So slightly over, but pretty close. The muffins will be 0.12. I actually can't remember what the muffin probability was. The muffin probability was, where are we? Muffin 0.133333. So we got 0.12. So we're over, but pretty close. So can't complain about that. And the last one, can't do this one on my head, so I'm going to get my calculator again. 19 divided by 25, 0.76. So based on all of that, the probability of 6, 7, or 8, which is the probability of a prize, would be all of those added together, 0.04 plus 0.08 plus 0.012, and that comes to 0.24. So we calculated that it was we had a 1/3, 0.333333 chance. So what that means is in our experiment, we maybe got a bit lucky. We won more prizes than we would have expected. So let's compare this to our theoretical probability. So our theoretical probability calculations show that there is a 0.24 chance of a student winning a prize from the 2 pride cards. Let's click that. So this is a lot lower than the 0.33333 probability we calculated as part of our experiment. Thank goodness for the autocorrects that were coming up. This means during our experiment or simulation, whatever you want to call it, we got lucky and won more prizes than we would expect. So I think that there would be enough to get you the mark. If you wanted to, you could make an individual comparison of the muffins, or you could even compare the no prize option. But given our question was, what's the probability of a prize? We've done that comparison and we've compared that to the theoretical outcome. So that's that one there. Before we get to the reflection on the experiment and the improvements, let's do the second insightful part. You only need one of these two at our school to get excellence. Every school is slightly different, so check with your teachers. But this comparison one, you're going to need to look at that graph, that time series graph we calculated. And what you can see is you can see the graph changes over time. So let's actually copy this graph. Let's move that down to where we need it instead of having it up there. Makes no sense actually in hindsight. So the graph above shows us the probability of winning a prize as the experiment progresses. We see that the experiment goes up and down around the probability of 0.3333, and I'll show you what that means. So imagine a straight line across 0.333. So what this means is it goes above the line, then below the line, above the line, above, and now it's below, and then it goes above, below several times, kind of near the end here. This is typical of an experiment, because the probabilities would fluctuate due to the randomness of the prize cards. And I just want to talk about specific things. So we can see we actually got real lucky to start off with. You can see at the beginning of our graph, we're way above the theoretical probability, which don't forget was 0.24, which is probably along there. And we're also way above our very nice experimental probability, which is just about there. So let's talk about this initially. So let's talk about the graph. So our graph starts at a probability of 0 because the first two trials resulted in a no prize. Following this, we were very lucky to win a few prizes back to back, which meant the probability increased to its peak at trial 8. Following this, we were very lucky. We were lucky, and its peak. Let's change all those. Following this, we only won one prize between trial 9 and trial 20, which, oh gosh, I can't even see my writing now, which is reflected in the decline we see. Following this decline, we see the graph fluctuate frequently, i.e. up, then down, then up again, etc. This is because as our sample size increases, the experimental probability will tend towards the theoretical probability. And that's why you see, instead of the graph, leveling off at the peak here, because the theoretical probability was down here, the graph would have these wild swings, and it'll settle in roughly at the theoretical probability, but not quite the theoretical probability. So that's this. That wasn't the best discussion in the world, but it'll be enough to get you the mark. We talked about the fluctuations we see in experimental probability, and we linked it to the theoretical probability that we're expecting. So the last thing we need to do is we just need to think of some improvements, some reflections on this here. And it does have to relate to the graph. So let's copy above. So at the marking schedule we have at my school, I've got some examples. So Control C that we can talk about for reflection. So let's just copy these down here so we can see them a bit easier as we do our work. So Control C. So first thing we could do, we could reconcile our conclusion with the prediction that we drew. So earlier in this investigation, we predicted that, and then let's scroll up. What did we actually predict? Let's have a look. There you go. So we predicted that the 8 was the least likely, 7 was going to be more likely to occur, and 6 would be more likely to occur again. And we've got the combination of prizes, the other combination of numbers, which would have been the no prizes. We're expecting that to be the majority of that. So it looks like our prediction was actually really good. Okay, so where are we? We predicted that, number 1, 8 would least likely, 7 would be more likely than 8, and 6 would be more likely than 7. This, or our graph, our bar graph has shown this to be correct. The probability of 8 was 0. Showed it to be almost correct, because we remember that in the graph that 7 and 8 were the same. The probability of 7 and 8 was 0.1, and the probability of 6 was 0.3 or 13333. This means they were all unlikely to happen, but 6 was more likely than 7 and 8. Okay, we also predicted that the probability of winning a no prize will be a lot more than the probability of winning another prize. So we predicted that the probability of no prize will be larger than the probability of winning a prize. It was found out that the probability of winning no prize was twice as large as the probability of winning a prize. And that's maybe just in brackets 0.66667 CF. If you're not sure what that means compare 0.33333. There we go. Was twice as large. There we go. Okay, and the thing maybe we didn't predict, 3 really got us in a show. Our prediction did not predict that 3 would be the least likely to occur. Okay, so we've done the first one. We've reconciled it with a prediction. Now the second one, identify and discuss the sources of variation, including the impact on calculations. So this one's actually going to be a bit interesting because the random calculator or the random spinner assumes that the events are independent. So the random dual spinner is completely random. So completely, which assumes pride card 1 is independent of pride card 2, i.e. that means there is no change in probabilities. However, if you think about it, if you're actually dealing out these pride cards, so let's say you're given the R pride card, that means there's one less of that to give out to someone else. So what that means is, even though it maybe is ever so slight, it means the probability of getting an R is actually slightly dropped because there's one less available. And that's inconsistent with this independence thing that we're talking about above. So we can see the spinner doesn't quite match up with this scenario. Even though it won't make too much of a difference, because I assume there's going to be lots and lots of cards, so that drop in probability is going to be very small. That drop will exist though, whereas our calculations assume it won't. However, in the real world, if cards were being given out, the probabilities will not be independent of each other. For example, if I receive an R for my first card, the probability of an R will, or of AR will be slightly lower because there is one less available for me to receive. So obviously that's an issue. If you were going to improve this experiment, you probably actually want to go and get the physical cards and make sure you're really good at shuffling. To improve my experiments, I could print out lots of pride cards to make sure this slight change in probabilities is reflected in my experiment. Okay, so that was one thing, one way to improve it. I'm sure we could think of some other ones, but that was the main one I was thinking of. So the next one I want to talk about is sample size. So 3 was really low. And our probability was actually quite high. So from my experiment, I found out that the probability of 3 was unusually low. And the probability of winning a prize was also unusually low. And that's when compared to the theoretical probability. When compared to the theoretical probability. So what this means is, because they're really low, because they're really different to the theoretical probability, that maybe means our sample's a bit too small. So this might mean our sample is too small. So just to note, saying, oh, my sample's too small isn't enough. You need to be a bit more detailed, like why is it too small? If I took a larger sample, I would expect the probability of a 3 to catch up to other outcomes, and I would expect the probability of getting or winning a prize to decrease to near the theoretical outcome. To improve my experiment, I would suggest running more trials. There you go. So I've got 2 really good improvements. So just to note, be really cautious with this sample size stuff. If you just say more sample size, you're not going to get that. There needs to be a reason, or there needs to be some kind of relationship with the probability, either theoretical or experimental, to get that. And then the last one was consider the reliability of our estimates. And because some of ours, like we talked about before, the 3 and the prize was quite off the theoretical outcomes, I'm not super confident with my predictions. So because the probability of getting a 3 was so low, and the probability of winning a prize was so high, so high, and both of those are when compared to the theoretical probabilities, which we calculated below. I am not confident in my estimates, or my estimate. I would hesitate in giving this information to the deans. So you may be like, oh, yep, I've got a really good one, I want to go to the deans. But here I'm like, oh, I'm not too sure. I think it would be a good idea to do more samples before I pass it on. So let's get rid of that power button. There we go. So that there is really good timing because my power and laptop's just about to die. But that's perfect. So what we've done is we've done all of the excellence parts of our report now. So it ended up being quite a long video. But just a reminder, for achieved, all you need is that red stuff. For merit, you need the blue stuff, and pink is all the excellence stuff. And I do want to disclaim, you should get 3 lessons in class for this. So I did this in 1 hour 20, whilst being slow and trying to show you things step by step. With 3 lessons, you should be able to absolutely ace it. So thanks so much for watching. Hopefully you find this video really helpful. Now good luck for your internal.